My name is, well, we are going to do yourself as well, so you know, we are going to open it. My name's Keith Wigan. I'd like to introduce myself a little quicker than and I live we work for the HotSpot Runtime team at Sun. So this is the, of course, HotSpot being the JVM distributed with MSC. If you're looking at us, I mean, we're the team right now that's currently working on all dtrace related things, trying to get Java to work on dtrace. Trying to get dtrace visibility into Java, I should say. The way we're trying to approach all these things actually is we really just want to make Java and Java programs kind of equal to user level programs and the capabilities that you can do with Java things. So you can, we want to be able to be able to put probes in them manually in the programs that we provide things. Look at stack traces, read fields out of objects. Use a pin card where you can specify exactly which method you're interested in and kind of only do that. As well as on that, we want to actually put some probes in the VM itself so you can track what the VM's doing as part of your software stack. So if you want to see what your time spent in garbage collection or piling out and stuff like that, we want to do that. So it's really a two-pronged approach. One being distributing the VM, the other one being making Java programs accessible to dtrace. And we're not there. I mean, we're partly there, and I'm just going to talk about like what we've done, what challenges we're facing to finish, and then what we're doing now, what we're going to get to hopefully someday. And we'll have a little demo. I had some slides. I didn't take that advice earlier. I took my time preparing slides. I'm not preparing jokes, so the teacher probably got slides. But now I'm not going to use my slides. Okay, so what we've done so far is we did mention add a number of USDT probes to the VM itself so we can track certain areas of class loading and garbage collection time and stuff. Now, a lot of it was based on Jared's work with an agent. We just took that stuff and actually put it directly into the VM so you don't get started an agent doing that. Another thing we added, as Brian mentioned, is helper for JStack. I don't know if it's called UStack or JStack.
It's a UStack helper.
Okay, UStack helper. Whereas, there is a block of code that we load to dtrace to help them detect what the stack is at runtime, so it can be attached to these different trace probes. And we have added a few coarse-grained Java application tracing probes, very, very coarse-grained. We've got method entry, method exit, and object allocation. Those are basically the only ones. And they work great. They'll tell you everything that happens, but they do have quite a bit of performance impact right now. So that I've turned on my phone, I guess start being able to start a flag, you're going to attach a JInfo to it, and have that turned on because look up the system. There is a cost there, unfortunately. I'll talk a little bit more about this. In general, we do have a number of challenges with working with the USDT stuff. Because as a user-level program, we can only use the user-level capabilities of dtrace. And we're really stretching it too. It's not a fault of dtrace. We're really doing things we weren't designed doing necessarily. And part of the problem is like, HotSpot, just in the name kind of tells what we do is look for places in the code where it's executed a lot and compile that stuff. So we get a lot of generated code. We have a lot of generated code even in the runtime itself. So the way USDT probes work is you pretty much have to put your probes into an object file. And then when the object file is loaded, that's where you see those probes. Not all of our code is an object file, so that kind of excludes a lot of these areas sometimes. We are cracking that slowly, and we're in the process of cracking that right now and getting over some of that. So that's maybe not going to be a challenge for a while. I mean, all these are challenges. You kind of pick it over. And then all the typical things we have with Java, with any dynamic language or whatever, you're going to have non-native data structures. Our objects are not in native layout. For instance, field offsets can be all over the place. They're not unless that file type, for instance. Our stack frames are not native stack frames. We have our own format for these things. So doing things like this makes it tougher. The other thing that makes it tougher, of course, is if my boss made me promise that I would, as sending me out here, that I would ask for help. Because we're all open source now and stuff too, the local Java and Slayer, so he made me promise I would ask. Anybody who is interested in this or really wants to help get done, please let us know. Other non-technical challenges I should have mentioned, maybe it's just, in the past and in the future, is we're always a step behind Solaris. We were defined, our build was restricted until 14.6 on Solaris 8. We couldn't build Solaris 10. That made it pretty tough to have firms. Stuff we have stuff didn't help us there. We got it in, but sort of helped. It helped a lot. We don't do it otherwise. And some of the things that happen now. In case 7, that's not going to go for a year or two, but still, that's going to be source 10 by platform, not be source 11. Source 10. So we're going to miss out on some of the new features. Not be on the leading edges we like to be. Some of the stuff maybe we can check at runtime and link in and stuff, but right now the current state, I think JDK 6, I believe, we got the code in such a state that we didn't even have the existing approach in time that we would go with. So we're kind of stuck without them until we get close, until we can build on newer platform. Okay, so back to the technical problems that we run into. As I said, our type system is different. Our strings are like airline. We're not care structures. They're real-time objects with a header and a length. And code byte array actually just points to the byte array, so it's not just a regular string. And of course, people don't want to dtrace over for strings. Regular things that's just not what we have. So it's tough to do that translation sometimes.
I think also we can change it. Sorry, Mike. No, I was just going to say, actually that's something I think we get the feature section later, but I think everybody here, especially you guys, review that, all that stuff is changeable and extensible, and also especially when it's common. I think that adding support for UTF-8 embedded strings or UTF-16 arrays is not that hard, because most of the user land and would benefit a variety of different runtime environments. So I encourage everyone to tell us, it would be good to maybe at the end of the day when we're talking about features, come up with sort of a list of things that would benefit the most number of different environments. But that one's easy.
We don't convert our strings to UTF-8 when passing to the dtrace, but Java internally use UCS.
Right.
Which can contain 0 bytes.
Right. But having just like we have copy in or we can have copy in U16 or UCS or whatever. We can do that. It's all just software. So
part of the problem with Java problem too is that people use just string to give a string representation. Of course, it's like one insert to string. You end up having to execute actually user-defined code in order to be able to get some sort of user-recognizable representation of an object. That's a bitch of a problem to have
because we can't call out into Java from
and users can and do arbitrary things from just string. So
Okay, I'll learn some feelings now. This makes tons of sense for Unicode. Like absolutely fine with dtrace working. But we're laying lists straight. If I have to implement some bizarre dynamic type once, why do I have to implement it a second time so that I can see them from dtrace? There. Replicate me yet? Okay.
I'm completely happy where I can go.
Yeah. Exactly. And I think we're in the same situation there. Right now there's just not the communication channel between dtrace and the application being traced. Besides a few places like the UStack where we can actually insert code to do these fast translation. I think there was some talk about user level translation. User level translator, right?
Yeah. Nice.
Dynamic translator.
Dynamic translators. I wonder if that was ever going to show up. That was the
I don't know where.
The bridge to nowhere.
Well, yeah. And that's resources are always.
Yeah. We got like what, a third of that work done.
Mike did his part, we just do our part.
But some Java is almost impossible to translate without loops.
Yeah,
It is pain now in my current work that I need to really unroll loops by processor in the language to get some estimation, or maybe the 10 iterations will be enough in this case, and maybe not.
In all these situations, we do have the information in the VM, obviously, in our data structures for getting this information. It's there, It's just written in C or, generative code, which obviously we're not going to have to dtrace call out to C to do some of this stuff. That's just not doable. But yeah, some of it is buried and needs to be iterated over to find where these things are. So that is a challenge.
You're iterating over your own internal structures?
That's right.
Okay. Interesting. I'd be interested to know what that is.
So, okay, that basically kind of wraps up our challenges. We're running out of the two major projects we have going on right now are the enhancements to UStack and the Java level USDT.
I can explain. The problem is that one of our dynamic compilers, which use some server configurations mostly, on Intel processors, 32 bits, use completely non-standard stack trace. and kernel.
It should be a capital crime to have, not have frame pointers in your code. Because there's
No frame pointers. So kernel dtrace kernel just fails to iterate stack. It can't print out any stack because it can't find the frames.
So this is an important point because I just like to point out this is like not just dtrace that needs this, right? You've lost all debuggability whatsoever when you don't have stack frames.
No, that's not true.
And
Oh,
for
okay.
work like
Because
supposedly
usually-
tells you how to walk the stack, and GDB can never do it.
Right.
Right.
Well,
And
GDB, there are tools, see, we wouldn't get in hot water for this if there weren't tools that could do it.
Are you gonna go on
like
the work on
PSAT
that?
can do it. PSAT and trap as compiler frames, the units from PSAT. The way it works is that we provide a library that PSAT calls and.
Like literally, see, like everybody has 5 different GDB binaries they keep around, and you get a core, you get a ring. So sometimes you need GDB 6.4 built for 64 bits, and that one will get the stack trace.
We don't have problems. This is doable for our stuff anyway.
But do not compile with omit FP. Thank you, Alan, to change the X over to not. So,
Yeah, this isn't a not FP compilation. This is our generator code. It's not a matter of changing. Not a matter of changing the flag file. Unfortunately,
This is the senator from Texas, that's the reason why she.
Yeah, yeah. That's why we're working on it. It's one of our priorities. Which is good. So yeah. So those of you on the mailing list have maybe seen the proposal we sent out, which is to add a couple of additional helpers that can help us, as well as having the frame pointer available where it's usually found, which is the problem. The other problem is that the server compiler is very aggressive in terms of optimization, and it will actually inline many activation frames, Java activation frames, into one stack frame. And of course, it has that information as to it knows which ones are in there, but you're not going to find that on the stack. So another project that we're looking at as part of this is to enumerate with the JStack command, enumerate all those inline frames so you can kind of see what's going on.
yeah, Matthew, it's good for you to wait. Matthew, as you're waiting to air, you stack over on air. It'd be good to go back through and modernize the UStack helpers, such as they can be modernized.
Good job classing that up.
Yeah, thank you.
Okay, so that's the JStack one we're doing. The other thing is the USDT stuff. I'm not looking to do anything creative here. I'm just trying to copy the USDT at the Java level. You'll find that this is a whole thing we just copied. Okay. So we call it the Java statically defined tracing. Because of certain reasons, we had to make it, Java runs across platforms, so we can't make it run on Solaris platforms. So when you're looking at this in code, you're not going to see any mention of dtrace. It's just like the generic tracing framework. By the way, the code you won't see for a little while anyway, because I haven't got back yet. So it's in the column-sun tracing packages where we're proposing to put it. And it's going to work a lot like the usual level of tracing does for data focus. You define a provider, there are quirks there. We're going to define a provider. The provider is defined as a Java interface. It's all Java, pure Java code. And then you have to register that provider to the system in order to get the throws working, essentially. Part of this is, again, just due to the impedance mismatch between how Java works and how data code works. There's no necessarily one place where we can just register everything and the program loads or anything like that. The Java classes are loaded and unloaded all the time, and maybe linked to the runtime and stuff. So that's why we have to kind of do things a little bit differently. I have an example. I don't know if you have an implementation of this or if that's a little too detailed.
I think we just show the demo, show
Show the demo? Okay.
maybe the code.
We do the demo, then maybe I'll talk about a few things.
Usually with like building your own doc and stuff, going through that for a few minutes could be.
Yeah,
just have to be and nobody else.
You should know about it. Yeah, let me just show the what the Java code maybe will look like first. So here's our this is our provider definition essentially. The annotations just ignore them, and then those path size. Really, what you look at is the interface and then the number of methods you're defining on that interface. So this is our definition file for the provider. These things, these annotations here are just tweaks. So you can set names, I won't see there, or So what this guy do is define a provider, because we set the name, the provider name is going to be primes, it's going to be a USDT provider, so in order to get anything, you want primes and the PIN number, and then the world name. World names are by default function names, if you override them, nope, so we use the function names here. Okay, so that's the definition. Now if you scroll down a little bit, you see that the first thing we have to use, this is the first time I've seen this example, so we have a provider factory that you get a system level provider factory. And the real reason for this is getting just a layer of abstraction so that you're not seeing what you're doing. Not necessarily a good thing, but it's something I have to do. You take your provider, this create provider call here is the call that you pass your interface class to. And what the factory does is it passes you back an object which implements that interface. So at that point, once you have that object, you just call, here, you just call your methods that the interface defines. And every time you do that, what happens in the Java program is absolutely nothing, because it's just a tracing call. And then if you're tracing this with dtrace, you'll see those probes, you'll see the fire go by. Right.
So is the disabled probe effect actually, is it 0?
No, it will never be 0.
Okay, yeah. How non-zero is it?
Right now, it's pretty badly non-zero. Probably. I haven't done any measurements, but I do some work that possibly also is doing that might be done by time, which will greatly improve it.
So you think you can drive it? There's no reason architecturally you can't drive it down to close to.
Well, there's a couple things that's going to prevent it from ever getting to 0. And one thing is the argument conversion.
Right.
Anything that's a string, we need to convert into the UTF-8. That's going to be a cost. With no arguments, it'll be much closer. But we'll always have a call. Here, the thing is too, the calling convention, especially for compiled code, does not mention native call. So any parameters that's coming in, the parameters aren't like, x8 to be on the stack after a frame point or whatever. That's not where they are. So they need to translate it into the right place. Right. So there needs to be a call to go in there and do that.
Adam, can they use this enabled probes to do that? Can they use it?
Yes, they can, but the problem is that when they're making
Text.
at the call site, they're actually making a call, right? It's like, and that's a Java call, and they would, if they sort of dusty that up in the interpreter, in the generated code, they could do that with this enabled, but that sounds like a lot of work.
We plan on doing just about that. Going in, the first thing we call does, you have to make that one call. It's going to go check the instruction to see if it's okay. If not, just return it to the okay.
Cool.
Otherwise, I'll go through and do the argument to switch it to down. So that the disabled probe effect will help.
That'd be great.
We'll think about that. Right now, for people who know Java, it's ugly. I mean, right now we call.
I can say that the penalty, main penalty is GNI code. Again, call the native code from Java code. It is very costly operation, as every Java programmer should know, really. It is in empty case, it's about 400 CPU cycles on Intel and even non-Spark.
That's what we're trying to avoid.
And we
compile these things pretty much.
We will avoid this penalty before release, we hope.
Yes, oh, definitely. Well,
all I did here was basically aggregated on the probe names. So there's three different probe names. And I also wrote a small script to, sorry for the size of this window.
So if you guys started talking about ISVs about this, I don't know, Jared, you talked stuff about the DEAs, the world, are they interested in stuff?
So I'm going to present this at Java 1. Part of the hands-on lab. So that's this example.
So we presented a very decent version of this at Java 1 last year.
It's going to be in Java 1 this year as well.
That's right. Yeah, not us. We're not.
Yeah, I'm doing it.
Yeah, more customers are interested in ISVs. One indulgence for Cole for X-rated analogies. You can't use the term money shot in front of 10,000 people. Fine, dtrace.conf, no problem. I'm not going to be getting dtrace.conf next year. Java 1, you cannot use money shot.
So you said. So here's what the dtrace syntax looks like. I mean,
So this is another one. Basically, what this is like I did a little thing for my son. He's in 6th grade, so we're trying to do a science project for trying to figure out how much power does it take on different machines to calculate 10 million primes, right? So I've been using that example with dtrace to kind of do optimizing. So all my Java 1 labs has got, how to calculate prime numbers in, in PHP and in Perl or whatever, and use dtrace on top of it.
Yeah, you really good must be involved in like better fathering through dtrace.
It was fun explaining dtrace to a 6th grader. But so this one is basically what it's doing is it's putting a probe in, and every time you look for a prime, it says, did I find a prime or not? So the argument that's passed to the string is a string called yes or no. So you can aggregate on that and see how many numbers did I have to search to find primes. The first 1,000 primes, how many numbers did I have to search? So let me. So it goes about looking at primes, and then it will eventually show up, and you can see that when it searched primes to find 2,000 primes, it had to search through 7,000 numbers, and then you optimize it, and basically only look at prime numbers, and then you can bring it down. So it's just a little example to show. The problem with in these hands-on labs is not dtrace, but use cases, right? How do you come up with use cases to kind of show off these things? So this prime number is a nice use case, so I'm kind of showing it to it.
Do you want to talk a little bit about how you implemented JSDB?
Sure. Right. So let's get with the idea. So I'm going to steal this thunder, but I can describe a little bit what we're doing.
Really, I repeat, Java is dynamic language, and the class can be loaded at any time. Static probes for native programs is implemented via new ELF binary file section, and a small stub which pass this section to the kernel via special device. It is what the dtrace team do. Really, what I do, I repeat this procedure in runtime. I generate the D-object format in memory. It is when you build the native program, the dtrace binary, user level binary is used for you by it takes your provider specification in D language and compile it, and then add it to ELF file. And I do this on the fly, really, in memory.
Okay, that is the money shot. I can say that. That's an appropriate use of that.
That's creative, yeah.
Yeah, that's very hot. That is so hot.
I use the Java structures, the interface definition, as instead of D language script, and generate this D-object format memory segment in memory and register it in kernel.
Just like USDB does.
Yeah, and of course, I generate for every probe, I generate separate small function in native code, because every probe should have the unique location in memory. This function is converting the arguments from Java calling convention to the native calling convention. It's platform dependent, of course. D-object format generation is completely object or system independent, and generation of stub is dependent on architecture.
That's awesome.
That is very cool. That you're hacking stuff without using a big dtrace, just generating your own documents like that. It's very clever.
Yeah, Keith is the Emerald guys. Take note. I think that's a real testament to the strength of that interface. That these guys were able to do that without no dtrace involvement whatsoever, just generating all that.
That's funny because I've actually done this with Ruby.
Oh wow.
To except that I add to dtrace. I have a similar provided definition in Ruby, and the SNT probes show up. But I've done it by actually emitting the generated H file, C file. So Ruby inline style.
Wow.
Very familiar with that, and then PLO the resulting sliding back in.
Oh wow.
I mean, it works, but it's quite horrible.
So you're running GCC as part of your tracing environment? It sounds like
Yes.
Sounds like how that
Yeah. So one
So
reason
the reason we can get away with doing this is because we have assemblers built into the
Yeah,
the
the kernel line assembler in our system.
So Chris, the dot format, Mike did a fantastic job documenting the dot format. If you need an object format, Shapiro's your man. If you go to dtrace.h and dtrace.h, I can remember the dot header files, I can't remember what it's stuff, but there's the dot is very well.
It's just sitting in the dtrace.
Yeah, I think it's just dtrace.h. The dot is very well documented, and you should be able to generate that.
Do you still load in an extra block of text to create the address for your probe to sit at? Because that's the other thing is,
We have code buffers. We have code buffers that we generate code into. Yes. So we have this little stub code of 5, 6
but
instructions.
you don't do that internally.
Yeah, I mean, we do that all the time anyway. So I do, and then we just need to do all the magic to route flow control through that stuff. Which basically does nothing more.
Also, we have one. I can say that we have one thing that is better for us than for C compiler and user static defined probes. Is enabled probes work in Java on any system, on any kernel, because we can create code which pick memory and see it is no instruction or interrupt instruction.
Nice. It's like it is enabled.
We don't need is enabled.
Our first version we
is enabled mechanism.
We'll do it ourselves.
That's great.
So
Cool.
that's cool.
Awesome. Guys.
Looking forward to seeing stuff like this document on the wiki, proposal to dtrace stuff would be great too.
Yeah.
When is this going to be in the next version of Java?
Yeah, JK7 is a few years now. We're still with it. We have open material repositories now, but we've been prevented from using it for a while. This is internal stuff going on. As soon as we clear that hurdle, which hopefully will be in a couple of weeks, the stuff should get there. We go to, let's see, this is a slide. The only slide I didn't want to show was hg.openjdk.java.net. That's where all this stuff is going to show up eventually. This and stuff. The other things I just want to touch upon is just the future work. Some of we haven't got to yet. See us getting to it until we get all this stuff done. But it's just improvements to one of the things is the improvement to the JST interface, which we'll probably get to actually.
JSDT can now pass the integers of all sizes and strings, and the strings as arguments. No Java objects, no floats, no complex types. Only the basic types. Strings are converted to UTF-8 and integers in the
So things we're still looking into, and if anyone has any ideas, we'd love to hear about it. This the holy grail, as far as we're concerned, is the Java level pit. Something where you can dynamically turn on any method you want, right? You can have some method entry stuff, which turns on for everything, and it's really bad. Slow. But the pit provider, is something where obviously you would just say which Java methods you want and how to get it back. And we have some ideas on that. We haven't really written them down anywhere because so far we're heard while thinking about it anyway. So, but if anybody's interested and wants to work with us on that, we'd be very happy to Wikipage and start discussions and stuff. Java object field access, class field access is a big thing that would be very useful too. And this is part of those things where we have the information in the VM as to which offset in the object field is. It's just not clear how to do it with the current dtrace mechanisms. And then just some enhancement to existing support, which we might just throw away if we get some of this other stuff working, like adding more probes in the VM. Well, that's always a good thing anyway, so people want probes in certain areas. Right now, we call these the expensive probes, and then I'll let them dynamically turn those on as dtrace asks for them, rather than turning them on all the time, or via some flag, or via some tool, external tool. And that may just be something changing the dtrace executable or whatever to pause when everyone's interested in some of these things. And then with these probes, we love to pass some parameters, some return values. Once again, it's one of those things if we have Java pid for, these things we won't need it all anyway, so we'll throw that away. Those are the things we'll think about.
So is dtrace helpful to understand, for example, garbage collection in Java?
Yeah. Oh yeah, probably. I don't do that stuff.
Surely yes. I work in one room with two guys from garbage collection team, and they use the dtrace regularly to understand some garbage collection problems. Because there is many state probes and garbage collectors now.
We could have like javacollection.conf and just a day of Jared talking about that. So. All right, thanks a lot.
Cool, thanks guys. Anyway, we opened that session. I think that was incredibly valuable. A lot of great stuff there. Thank you all. All great presentations, great stuff. So let's go ahead and take we'll take a 15-minute break. I think this is like shipping software, where like you slip your schedule, and then you feel if you make your slip schedule, you're actually on time again, and then you slip again.
I don't know what you're talking about.
Why don't we'll reconvene at 3 and see if we can get, we're trying to catch up here with distributed visualization. And so how long the databases are, I think we'll just get into it, so you can see where we are next. Okay, good, so let's reconvene at 3 o'clock.